So at the top of page 91, workbook pages 91, you need to have angle bisectors. This is talking all about angle bisectors, and you need to have this sentence. Any point on the angle bisector is equidistant from the sides of the angle. Now, we have talked about this time and time and time again about finding that distance from a point P, to a line. We've talked about this many times. Back in the day, there wasn't like a universal law. They didn't know how to determine the distance between a point and a line. And so people could just come up and say, no, I want to measure this length. That's how far away point P is from that line, whatever this distance is. And some guy came up and said, no, it's a little bit shorter. It's that distance. That's how far away point P is from the line. And some other guy came up and said, no, idiots, you got to go to the right. The right's always better than the left. Everybody knows that. And so that's the distance from the point to the line. Well, who's right? Because that's three different answers. And someone could just come up and say, no here, no there, no here, no there. Whenever you're talking about the distance from a point to an object, like a line, or a ray, or a segment, or a side of a triangle, or a side of an angle, or a plane, it has to be the perpendicular distance. That is the distance that they're talking about. So, when you wrote this at the top of the page, that if a point is on an angle bisector, and you wrote that it's equidistant from the sides, you have to know that that distance is the perpendicular distance. It has to be the perpendicular distance. If you don't know that it's perpendicular distance, then you cannot conclude that that point is on the angle bisector. You have to know it's the perpendicular distance. So let's look at some of these examples. There's two ways of proving that a point is on the angle bisector. There is two ways of proving that a point is on the angle bisector. The first way, number one, the easiest. You can just look at the diagram and realize that you have the angle bisector. Why is ray BD the angle bisector? How can we just look at this and know that ray BD is bisecting angle ABC? What's that?
It gives you that the two angles are congruent.
Yeah, marks of congruency, right? So this is the easiest way to determine if you've got an angle bisector or if that point is on the angle bisector. It just shows you. It just shows you, hey, you got the angle bisector. So number one, that is the easiest case. They are just handing it to you and saying, hey, this is the angle bisector and point D is clearly on the angle bisector. So what do we know about point D? How could you describe it with respect to the angle? Yes, sir?
It's equidistant from both of the sides.
It is equidistant from the two sides of the triangle. Now I warned you. Remember, when you talk about equidistant and you're talking about the distance of a point to objects, it's got to be that perpendicular distance. That's why it's so important that they put those right angle markings, because they're telling you, okay, you are dealing with that perpendicular distance. If that's the case, what's the length of segment AD? 19 units, because it's equidistant. The second way to prove that you have the angle bisector, or that a point is on the angle bisector, the first way was number one. They just give it to you. They just tell you, hey, this is the angle bisector, by showing you marks of congruency. Second way is what you wrote. If you can somehow prove that a point is equidistant from the two sides, then it has to be on the angle bisector. If you can show that a point is equidistant from the two sides of an angle, then you have the angle bisector. So, why do I know that ray FH is the angle bisector? What is this diagram showing us? What's up, David?
The distance from H is equal from line FE and FG.
Correct. It's showing us clearly that point H is equidistant from the two sides of the angle. That's what it's showing us. And you should have written down earlier that if you have a point that's equidistant from the two sides, then it's on the angle bisector. So that's how I know this angle is being bisected. Because I know that point H is equidistant from the sides. I know that these segments are congruent because it's marked, and I know that they're talking about the perpendicular distance. You have to know that the segments are congruent and it's the perpendicular distance. Those are the two ways of proving you got yourself the angle bisecting. Okay? So that's how you do 1 through 3. Pretty much already solved those for you. But 4 through 6, these are a little bit more tricky. You have to determine, can we conclude that ray BD bisects the angle? Two ways of proving you have the angle bisector. What's the first way?
It's given to you.
It's clearly marked. It clearly shows you that the two parts are congruent, that the two angles are congruent. Is that happening in 4, 5, or 6? No. Alright? So we're going to have to work a little bit. So what's the second way of proving that we do have an angle bisector, or we have a point that's on the angle bisector? What must we show or convince ourselves? Yes, ma'am? So let's check that out. Let's see if we have a point that's equidistant from the two sides. Number 4. We're trying to prove that ray BD is the angle bisector. So can we see or prove or show that D is equidistant from the two sides? No, because we don't know those lengths. It's talking about the perpendicular distance, which is good, but we don't know if it's the same. So no, we can't conclude. We have no idea how far away D is from A and D is from C. Number 5. It's not marked, like marks of congruency to angles, so can we prove that point D is equidistant from the two sides? I hear yes and I hear no.
It's not. There's no marks of that show it's perpendicular.
This is, you have no idea if you're talking about the perpendicular distance. So because we do not know we're talking about the perpendicular distance, then you cannot say that that is the angle bisector. Here is a very drastic example. Okay, so it kind of looks like that was the angle bisector. But again, you can't assume anything in geometry. So here we go. Let's check this out. So I've got angle. We'll call it X, Y, and Z. And I have some ray. I'm going to purposely draw it so that it looks like it's definitely not the angle bisector. Okay? Absolutely, this is not the angle bisector. Okay? So, just because I say that this point, and I give you two segments of the same length, that doesn't mean anything. Because I could say, okay, well from this point, that means this is 10 millimeters. That distance is 10 millimeters. And then, this distance is also 10 millimeters. So I'm giving you two congruent segments. Is that the angle bisector? Absolutely not. I mean, it's evident that it is. So this is a very drastic example of why we cannot say number 5, we cannot conclude that that's the angle bisector. Because it's exactly like them telling us this. They just give you two congruent segments. Say, hey, this is 6 units, that's 6 units. Okay, well that means nothing to us. We have to know you're talking about the perpendicular distance. And this is obviously not perpendicular. This is obviously not the angle bisector. Okay? Well, let's go to the next page. Let's go to the next page, page 92. 92. On page 92 at the top, we're going to write some more notes at the very, very top. Again, this is all about the angle bisector. So at the very, very top of page 92 of your workbook pages, all about angle bisectors. So go ahead and write angle bisectors. And then to the right of that, put POC, which stands for?
Point of concurrency.
Point of concurrency. What is the point of concurrency for your angle bisectors? Yep, in center. So at the very, very, very top, you should have angle bisectors. Point of congruency is the in-center. This is what you need to know to remember about the in-center. And this is on your point of congruency chart, but the in-center is equidistant from all three sides of a triangle. It is equidistant from all three sides of a triangle. And if you need to go ahead and make a little mark, what do you need to remember about equidistant and a point to an object?
Same distance.
Same distance, what else? Perpendicular. If you're talking about a point, because the in-center is just a point, if you're talking about a point and its distance to a side or a segment or a ray or a line or a plane, some object, you got to know that's the perpendicular distance. You didn't have to worry about that with the perpendicular bisectors because it was the distance from the circumcenter to the vertices, which were just other points. So you didn't have to worry about if it was a perpendicular distance because it was just the distance between 2 points, vertex and circumcenter, vertex, circumcenter, vertex, circumcenter. That's easy to find the distance between 2 points. But when you're talking about the distance from a point to a side or a segment, you gotta know that's the perpendicular distance. Okay? So, 10, 11, and 12, that's just like that's just like page 91. However, it's not until 13, 14, and 15 where you get into these in-centers, right? So number 13, let's look at this one together. First off, I have triangle ACE, and inside this triangle we have 6 segments. We have 6 segments. You need to be able to read the instructions and determine what these segments are representing.